Hello, today's video lesson is on titrations. All right, we're going to look at what titrations are. I'm going to talk about how we use titrations, and I'm also going to talk about the three general types of titrations that you're going to see. At minimum, what a titration is a controlled buffer system, is really what we're dealing with here. We're going to use this thing called a burette to analyze a substance. Okay, so our tool here that we use is the burette. Down here in this flask, what we're going to do is we're going to put down our substance that we're going to be measuring or analyzing. Okay, so this down here is what we would call our analyte because it's what's being analyzed, and up here would be called our titrant because it's the substance that we're using for the titration. Okay, so that would be our titrant. Alright, so what do we do with these? One, we can find the concentrations of acids or bases in solution. So if I don't know what the concentration is of an unknown solution, which you're going to do, you'll do that in a lab, you'll figure out what the concentration is. You did that in honors chemistry as well. The next lab we're going to do is actually to find the Ka of an unknown acid, and that would be another way we would use a titration. Find the molar mass of an unknown compound, oxidation state of metal ions. I mean, there's a lot of uses for these titrations. So, alright. So what happens during a titration is as we add, first of all, most of the time what we put in here would be something like sodium hydroxide. Okay, we would put sodium hydroxide would be our titrant. What we do is we add the titrant to our analyte, and our analyte tends to be some kind of acid compound. Okay, so what happens is as I add the base, the reaction happens and my pH changes. So if I have a base up here and an acid down here, my pH starts out pretty low, and as I add the base, my pH starts to go up and up and up. So what I'm going to do is I'm going to analyze my pH as I add more and more of the titrant to my solution. What I'm going to do is I'm going to talk about the three types of titrations: the strong acid, strong base. So that means that I would have strong acid here, strong base up here, strong acid down here, and see how they react and look at what happens as I add the substances. Then we'll do is we'll look at a weak acid. So I'll substitute a weak acid in here and then do the titration. And then the last one is I substitute this with a strong acid and put a base down here, in this case a weak base, and do the titration as well. Okay. The two that are the hardest are these two here. This is the one we did in honors chemistry. So we dealt with this in honors chemistry. This is pretty much very general stuff. Okay, so let's take a look at all three types one at a time. One we're going to look at is a strong acid being titrated with a strong base. So again, as I said here, we're going to have sodium hydroxide. It's going to be my strong base. And in here, inside the analyte, what I'll have is HCl. Now I'm going to stay away from doing calculations here. What I'm going to be doing is really talking more about the reactions that are going to go on inside of the container and talk about the background and look at what's called a pH graph, okay, or a pH curve. All right, so what I'm going to do here is I'm going to plot the milliliters of sodium hydroxide, and what I'm going to plot up here is my pH. Okay, so before I do anything, I'm going to measure the pH. My pH, because I have a strong acid, is going to be really low. So it's going to be really low down here at the beginning. Now as I add the base to this, what's going to happen is I'm going to get a chemical reaction, and the reaction I'll have is based on the fact that I have, actually what I should do is list the species present, right? So let's see what species I would have here. In the beginning, I just have H+, Cl-, and water. So this is nothing more than a strong acid problem. So all I would do is take the concentration of the hydrogen ion, take the negative log of that, and I would get my pH. The nice thing about these types of titrations is that there is no equilibrium, because what we're going to have is all strong acid, strong base stuff, so therefore no equilibrium is going to be found. Okay, so we do no ice table. Okay, no ice table. Everything we do here will be a BCA table because we're going to be dealing with stoichiometry. Okay, so everything's going to be stoichiometry. Alright, so the first thing I do is I calculate the pH of the solution with just nothing added. No sodium hydroxide added. pH is down here really low. Let's say like 1.2 or something. Okay, now then I add the sodium hydroxide. Well, what I have is Na plus and OH minus. Alright, well, if I analyze what I have here, I have an acid. I don't care about the chloride. Water, yeah, it could do something, but in this case, again, it's not. Sodium ions don't do anything, and I have a base. So what's going to happen is these two are going to react together. So what I have is hydrogen ions plus hydroxide ions give me water. So all I do here is a BCA table, and I figure out which one I have and which one I have at the end. So it's see how much of the hydrogen and how much of the hydroxide. Well, depending on which one runs out, let's say the hydroxide runs out, I have excess acid here, right? This is the excess reactant, and this is my limiting reactant. The solution is still going to be acidic, so therefore it's going to go up, but it's not going to go up drastically. So we're going to get as a point here. All right, I'm going to keep doing this and keep doing this and keep doing this, and eventually what happens is the system is going to eventually, more and more of the hydroxide is going to get added to this. I'm going to have less and less acid. So eventually I'm going to get to a point where this no longer is my excess reactant, but they'll both be the limiting reactant. That's a special point. Okay, so if I keep doing this, this curve is going to look like this, and then all of a sudden it's going to go up. Whoops. Curve's going to go like this, and then all of a sudden it's going to go up, and boom. And this is typically what our curve looks like. Probably a little bit more of a curve right in here, but you get the idea. Okay? So what we have down here is our acid, is what we have down here at this portion. Up here we have our strong base dominating, and in the middle here, right here is what we call the equivalence point. I don't like to call this the neutralization point. I prefer to call it the equivalence point because this isn't always going to have a pH of 7. But for these particular problems, the pH will be 7 for these. So when we get to the equivalence point of a strong acid, strong base titration, the equivalence point is going to be equal to 7. Why? Because when we get to the equivalence point, what are we going to have left? Well, if we list the species present, these are gone. What we're going to have left is chloride ions, water, and sodium ions. Well, we know that the chloride ions don't do anything to water, and we know that the sodium ions don't do anything to water. The only thing that's there is just the water and two ions, a cation and an anion, that have no effect on the pH. If you remember, we talked about hydrolysis of salts, so therefore we have a neutral solution. Okay, and then if I continue on beyond that, then this becomes my excess reactant, and this becomes my limiting reactant, and therefore I have a base left over, and my pH goes over 7. So very general, type of titration: strong acid, strong base titration. Before I move on to the next type, I wanted to mention one other thing. What if I flip-flop these? What if I put my sodium hydroxide down here and I put a strong acid here? How would that play out? Well, it's going to be the same thing, just the opposite direction. So what I would have here is milliliters of HCl that I would add at the bottom, and on the top I would still be looking at pH. I'm always going to be looking at pH. And what I would have is it would look the opposite. I would have it start out with a base, and then all of a sudden it would drastically drop, and then I would get my acid. So it would be the inverse of the other reaction that I saw. So I'm not going to keep doing this and showing you the opposite. You can probably figure out what happens once I figure out, one way. You can flip it over and see what happens with the second one. Okay, so now let's go ahead and take a look at the weak acid, strong base titration.